Have you ever noticed how it feels easier and quicker to fight off a disease after you've had it before? Well, that brings us into the world of immunity. Immunity is the body's ability to defend itself against diseases, and it does this in many ways. We have two types of immunity: innate and adaptive. In innate immunity, we have physical and chemical barriers. Physical barriers block the entry of pathogens into the body physically. This includes skin, earwax, and hairs, which all trap dust and dirt from entering the body. On the other hand, chemical barriers block the entry of pathogens at body openings and inner body surfaces. Examples of this include saliva and mucus, which contains enzymes that break down these harmful substances. Adaptive immunity uses specific antigens to strategically mount an immune response, which is what we'll be talking about today. I know, all these terms sound foreign, but by the time you're done, you know exactly how the body does what it does. But before we do that, we need to familiarize ourselves with some key terms. The blood is made up of different cells, but the cell responsible for immunity is known as the white blood cell. White blood cells help our body fight off infections and diseases. We have a type of white blood cell called lymphocytes, which help our body fight off foreign substances. Under lymphocytes, we have B cells, which produce antibodies. Now, if you've noticed, I've used the word harmful substances many times since I started, but in biology, these harmful substances are known as pathogens. Pathogens are microorganisms that cause diseases like bacteria, viruses, and fungi. Pathogens contain little proteins on their surface called antigens that tell your immune system whether something in your body is harmful or not. In the same vein, get it? We have antibodies, which are proteins made by the immune system to fight against specific diseases. Antibodies recognize antigens using the lock and key mechanism. The shape of the antibody's active site must match the shape of the antigen for it to bind and destroy the pathogen, preventing it from entering cells. When a pathogen enters our body, white blood cells called B cells recognize its antigen. B cells produce antibodies that fit the specific antigen. Then, antibodies tag the pathogen for destruction by other immune cells. Some B cells turn into memory cells, which remember the pathogen. So if the same pathogen attacks again, your body remembers it and can produce antibodies faster. Some form of vaccines contain weak or inactive pathogens that trigger an immune response. So when administered into the body, your memory cells remember it and your body creates antibodies to fight against it. An immune response can present itself in many ways, in forms of fevers, rashes, and so on. So there you have it, the immune system simplified. So next time you have a fever, don't forget to give your memory cells a pat on the back. They're working overtime so you don't have to. Thank you.